So in the next part, we'll discuss about this concept of escape velocity. So in the last part, we discussed that when the total energy is equal to a negative value, it indicates that this planet or the satellite is it in the gravitational field which is exerted by the planet, or the satellite will not be able to escape. So this total energy negative represents the boundness of that particular satellite or an object with the planet. So the condition for escape velocity is when the total energy is equal to 0, or we can say that when the value of total energy is greater than or is equal to 0, then the object is able to escape from the gravitational force exerted by the planet. So under the heading of escape velocity, basically we'll discuss two types of escape velocity. One is escape velocity of an object from the surface of a planet, and second one is escape velocity of a satellite from its orbit. So first of all, just try to understand the escape velocity of a planet from the escape velocity of an object from the surface of a planet. So over here we are considering that we are keeping an object on the surface of a planet. So let's say the mass of object is equal to m, and mass of planet is taken as cap letter m, and radius of that planet is equal to, take it as r. So Rm is to find out with what velocity we should project this object from the surface of planet so that it will be able to escape from the gravitational field or gravitational pull which is exerted by the planet. So the concept will remains same for any escape velocity question. We'll use the same concept, that is total energy should be greater than or equal to 0. So the minimum condition we can write total energy should be equal to 0. And we know that this total energy is the sum of kinetic energy plus potential energy. So this is kinetic energy plus potential energy of that object. And if it is projected with a velocity v, we know that its kinetic energy is half into m into v square. And we know that gravitational potential energy is minus of g into m divided by distance, that is r. So the condition for this is this velocity or this value should be greater than or equal to 0. So we can write the value of half into m into v square should be greater than or is equal to gm divided by r. So we can cancel this m and this m. So this escape velocity is not going to depend on the value of mass of that object. So we can write this velocity square as equal to or is greater than or equal to that of 2 into g into m divided by r. Or you can write the equation for escape velocity is under root of 2gm divided by r. So we can use this equation for the calculation of escape velocity of an object from the surface of planet, and the equation is Ve is equal to root of 2gm divided by r. Now the same equation we can write in terms of acceleration due to gravity, because we know that acceleration due to gravity on the surface of a planet is gm divided by r square. So just to write it in terms of gm by r square, what we can do is we can just multiply this equation with r and we can divide it by r. So this is going to be gm by r square. So the value of escape velocity will be equal to, we can write 2 into this gm by r square can be written as acceleration due to gravity on the surface, g naught into r. So even we can use this equation also for the calculation of escape velocity. First equation is in terms of radius and mass of planet. Second iteration is in terms of acceleration due to gravity on the surface of planet. And just remember an important thing, that this escape velocity depends on the speed and it is not depends upon the direction of projection. So irrespective of its direction of projection, means it's not necessary that we should always project this object in a perpendicular to the surface of planet. You can project it in any direction, it will be able to escape. So escape velocity is not depends upon the direction of projection. Now according to this equation, if you are calculating the value of escape velocity on the surface of Earth, so if you are calculating the value on the surface of Earth, then you will get it as something like around 11.2 kilometer per second. That means if you are projecting an object with a velocity which is equal to 11.2 kilometer per second, it will be able to escape from the gravitational field of Earth.